Our next topic is learning how to calculate equivalent rates on the financial calculator. So I'll give you the steps here. And basically what we're doing is we're using the I-conversion function on the financial calculator. And we're going to follow these steps to calculate equivalent rates. And we're going to go through example 2 right now, and I'll show you how to solve for equivalent rates. Example 2, find the nominal annual rate of interest compounded semi-annually that is equivalent to 9.6% compounded monthly. So in this question, we're given two interest rates, one of which is given to us, and the other one we need to solve for. And we're given the 9.6% compounded monthly. So what we're given here is that one of the nominal interest rate is 9.6%, and that nominal interest rate of 9.6% is compounded monthly. So IY is 9.6, and then CY is 12. So this is the first interest rate that we're given, 9.6%. IY, CY is 12. And for the second interest rate, we know that it is compounded semi-annually. So the compounding per year for the interest rate that we're solving for is 2 times a year. That's the CY for the interest rate that we're solving for. And basically what we're solving for in this question is that we want to find an interest rate that is equivalent to the 9.6% compounded monthly. So we're looking for the equivalent interest rate. So our first step is we need to type the 9.6% compounded monthly into the financial calculator. Then our second step will be solving for the equivalent rate. So once we understand the concept, then I'll show you how we can plug that into the financial calculator to solve for the equivalent rate. So what we're going to type in on the financial calculator first is we're going to type in second function, I-conversion. So second function, and then I-conversion. I-conversion is right above the 2. So we're going to click on I-conversion. And you will see the NOM. NOMs represent nominal interest rate, which is your IY. So that's why we put 9.6. And then we press enter. And that will set your first interest rate to 9.6%. And then we're going to go down 2 times. We need to go down 2 times. And then we're going to type in the CY. The CY is 12. And then we're going to press enter. So we're going to do that. We're going to go down 2 times. And then we see CY. CY we have compounded monthly. So that's why we put 12. And then enter. And then that will set our compounding to 12 times a year. So once we input the 9.6 and the compounding 12 times a year, we're going to go back up 1 times. And then we're going to see EFF. EFF is the effective annual interest rate. We're going to learn about that in a moment. So basically we go up and then we will see EFF. And then what we do is we press compute. And then this will give you the effective annual interest rate. We will learn about effective annual interest rate in example 3. So I'll talk more about that when we get to example 3. So once we press compute, then we have finished entering all the variable for the first interest rate, the 9.6% compounded monthly. Then we're going to move on to the second interest rate, the interest rate that we're solving for. So we're going to go down 1 time, we're going to go back down 1 time, and then we're going to get CY. CY is 2 times a year because now we're dealing with the second interest rate. So compounded semi-annually, so 2 times. So we press 2 and then enter. So 2, enter, and then we're going to go up 2 times. Back to NOM, so we're going to go up 2 times back to NOM, and then we press compute, and then we're going to get 9.794, and that is our nominal interest rate compounded semi-annually, and that interest rate will be equivalent to the 9.6% compounded monthly. And both of these interest rates are equivalent, and they will give you the same rate of return, and that's what the equivalent rate means. And how you apply this concept is that when you're investing money into the bank, you need to know not just what interest rate they give you, but you also need to know the compounding as well. Because the compounding could make a difference in your rate of return. As shown in the example, we have 9.79% compounded semi-annually. So the 9.79 is greater than 9.6, but their rate of return is the same. So when you're investing money into the bank, when you're putting money into the bank, what you need to know is that a higher nominal interest rate doesn't mean that the rate of return is bigger. You also need to look at the compounding as well.